Greetings, Dr. Wong. I am Heng Peng Yong, and this is my Lab 1 enhancement MNIST dataset with Keras and TensorFlow. And for this Lab 1, these are my main contribution. There are 4 points of it. So I will be applying a simple neural network, CNN, and ANN to this MNIST dataset. Then comparison of performance between simple neural network, CNN, and also ANN. Then train and compare the model with different batch size. The different batch size can be 16, 32, 64, 128, and also 256. So this is just the example of the picture MNIST dataset. So after putting in the MNIST dataset into the tree of the model, then we can get the result. It shows that CNN model showing the highest accuracy with 0.9862 accuracy. So after that, I will be using different number of batch size for this tree model also. So after applying them, after applying in CNN, simple neural network, after applying the different number batch of size in simple neural network, the validation accuracy, the highest accuracy is having batch size of 16. Then the lowest validation loss is having with a batch size of 1 to 8. Then for the next two model is CNN and ANN is 16 with the highest validation of accuracy, then 256 with the lowest validation loss. Then for the ANN is both of them are having a 256 batch size for having the highest validation accuracy and also the lowest validation loss. So that's all for me for this Lab 1 enhancement. Thank you.
So my name is Teo Cheong, and now I will present about using the facial MNIST classification with PyTorch to create the CNN and AN for image classification. So the primary goal of this lab assignment is to apply and compare the CNN and AN models for classifying the facial MNIST dataset. So first we import the library and loading and preprocess the facial MNIST for CNN and AN and determining the computing device and calculating the size for the train and validation dataset, and create the data loader for CNN and AN. So here we see the architecture for our models. The CNN model analyzing the convolutional layer, followed by pooling and fulling connector layer, making it well suited for image data. So training involves building our models, define the loss function and optimizer, and iterating over the multiple endpoints type. We train the CNN using the baseline and learning rate operator for the CNN architecture. Similarly, the AN was trained using the parameter best suited to its architecture. So here we compare the performance of CNN and AN models. The figures show that the training and validation loss and the accuracy over the time. Compared to the AN models, the CNN models show a more stable loss reduction and a more rapid improvement in accuracy. So the AN, on the other hand, has greater fluctuation, suggesting that its learning is less stable. I will pass the time now to the next presenter.
Okay. Thank you. My name is Willie Yong, and now I will present lab enhancement for lab 4 regarding k-means clustering. So I have utilized a real-world data set describing penguins' data such as their body size and gender. Yeah. So upon the data exploration, I found out that this dataset contains both numerical and categorical data, and the numerical features are having varying scale. For example, the common length is having values ranges in 32 and 59, while the body mass values range in 2,700 and 6,300. This implies that there should be a data normalization before applying a k-means clustering to avoid bias introduced in which the k-means clustering algorithm is expected to place a higher weightage or importance towards those numerical features having a greater scale, such as body mass compared to the common length. So in addition, so three techniques of data normalization will be experimented, which are robust scaling, min-max scaling, and standard scaling. In addition, I also experimented with two different values for the init hyperparameter of a k-means, namely the k-means plus plus and random. So in total, there are eight k-means clustering models instantiated with different experimental settings. So furthermore, for each clustering model, the optimal number of cluster is decided using an elbow method. I have provided an improved version of the elbow plot in which the elbow location is highlighted in red cross marker. So now moving on to the model comparison part. So when we evaluate the model, we are using the COH score. So generally, COH score is a cluster validation index that measures the intra-cluster tightness and the inter-cluster separation. So in general, a clustering solution is good if its COH score is closer to a value of 1. So in this case, we see that the top performing clustering models are K5 and K6 since their COH score is the closest to 1. And both of them are actually using the min-max scaling. So this shows that the importance of data normalization when having varying numeric scale before applying a k-means clustering. So in addition, when we compare the runtime of different models, we can see that those even number clustering models such as K2 and K4 will be having a lower runtime than those corresponding odd number models such as K1 and K3. So K2 and K4 are actually using random init hyperparameter values. So this proves that in our case, the optimal choice for the init value is random instead of the k-means plus plus. So to summarize my contribution, I have applied a k-means clustering algorithm to a real-world dataset that show the importance of performing data normalization before performing a k-means clustering, especially when the dataset is having numerical features of varying scales. Then besides that, I also provide a clustering model evaluation method using the COH score, and I identify the optimal init value for our dataset is random. And not to mention that visualizations such as elbow plots and the clustering solutions are also made dynamic for interactivity purpose. And that's all for the lab 4 enhancement by me. Thank you.
Hi, my name is Pang Xuan. Now I will present the lab 5 enhancement. For this lab, I am implement the PCA and LDA to reduce the dimensionality of a real-world dataset and compare their performance. Now we look at the PCA implementation. First is the import library, and then we load the breast cancer data from the sklearn, and this is the dataset info. In the EDA, I found none of the columns contains any missing values. And this is the distribution of target values. And I use the ANOVA to find unrelated columns. And this is the ANOVA test result. And this result show there are 5 columns doesn't help in making prediction. So I load all of these unrelated columns. And then separating input and target. And do data normalization. using min-max scalar and finding agent values, agent vectors, and get the expand values. And this the expand variance plot. And this station is the linear transformation. After the linear transformation, select the one with the largest variance on the unit vector among all of the agent vectors obtained. And this diagram shows the top two PCS scatter plot. And I use the class grade to make better prediction. This station shows splitting the data into trend and validation set. And this is the conversion matrix for the PCA. And the results show that the PCA accuracy is 1. And this station is the LDA implementation. And this is the conversion matrix for the LDA. And the results show that the accuracy of LDA is 0.96. That's all for my lab enhancement. Thank you.
So now we will present our study on predictive modeling for customer loyalty and Starbucks Malaysia. So in the competitive Malaysia market, understanding and maintaining the customer loyalty is crucial for business success. So the aim of our project is to develop the predictive models that categorize the Starbucks customer into loyal and non-loyal group based on the characteristics such as income, time spent and Starbucks and other reliable factors. So by leveraging machine learning technique, we see to provide the valuable insight that will help the Starbucks enhance the customer experience and retention. So we analyzing the Starbucks customer retention Malaysia server data set, which is publicly available on Kagos. The dataset includes 121 individual response and capture the various aspects of customer experience and behavior. So the key attributes are divided into demographic information, customer experience, and customer behavior. The dataset comprises the 7 numerical columns and 40 categorical columns. This combination allows for a comprehensive analysis of customer satisfaction, breaking the quantitative rating and quantitative preference. I will pass the time now to the next presenter.
Okay, now I will present the understanding data and data cleaning part. So this is the original dataset. So from this dataset, we can find that the timestamp seems to be the index key. By using the timestamp, we found that the data is up to year 2019 and later. And then we check for data duplication. The results show that there are no duplicate rows. Since duplication has been checked, the index key is no longer useful and can be removed. And then we check for data completeness. The percentage of missing data is low. Hence, we simply remove missing data as it will not cause significant information loss. So from the dataset, we can find that there are both categorical and numerical data. Categorical data has to be encoded because some classifier only accept numerical input. Moreover, the column names and column values are quite long. Thus, it is a good idea to rename them into a more convenient format. So this is the new column name. Now we look at the column values. For the order type, Without that, they are duplicate value like never and never buy and don't like coffee. So we replace all of this value into one value, never buy, and this the result. For the purchase frequently, the result also have duplicate like the coffee. So we take out of the value and make them unique, and then rename them and concat to the survey data frame. And this the result. And for the promotion tools, it also has duplicate values. We take them out and make them unique and concat with the survey data frame. And this is the result. And then we can remove these two columns. And this is the latest column now. So in the EDA, we have shown some diagrams. This is the distribution of the data. And this is the correlation he made. And this is the class distribution of loyal customer. And this diagram shows the class imbalance occur. So, and we set the clean data into a new .csv file. And now I pass to team member to continue the presentation.
Thank you, Xian. I am Heng Peng Yong. In this project, I will be presenting the model construction. And in this project, we will be presenting two algorithms. One is logistic regression LR, and one is random forest RF. So for these two algorithms, we are using the default parameters, but with a fixed random state of 42, so that whenever you run the program, you can always get the same result. So the data pre-processing, including PCA and also SMOD, to overcome the class imbalance issue using SMOD. So baseline is without any additional pre-processing like PCA and also SMOD. Then PCA is using for reducing the dimensionality of the feature space. And then SMOD is used to handle the class imbalance problem. Then these are the 6 of the model code. We got 6 model code here, M1 to M6. Then this is the algorithm LR and also RF. Then for M1, we are using the pre-processing, which are the feature encoding plus trend test speed. Then for M2, we got one more here is PCA pre-processing method. Then for M3, we got one more. We're adding more pre-processing method, which is mode. So for M4 to M6, they are just repeating the steps for M1 to M3. Then for the model evaluation, we are using the performance metrics like accuracy, precision, recall, and also F1 score. That's all for me. Thank you.
Okay, thank you, Heng. I will complete the remaining parts of this video. So as previously mentioned, for each classifier we build, we are evaluate it using the metrics such as accuracy, precision, recall, and F1 score. The 20% unseen testing data is given to each trained classifier, and their achieved metric score is recorded and is shown as in a tabular form here. So we can see that the top performers are M1 and M2. Both of them are achieving a really high accuracy, precision, recall, and F1 score. In this case, we should just claim that M1 is sufficient enough to be the optimal classifier for our case, as its complexity involved is lower than the M2. When we look back at their respective experiment settings, we can see that M1 lacks of a PCA. So in this case, it means that PCA is not helping in improving the performance of the classification, and this is actually expected. Let's look back to our correlation matrix. We can see that the highest absolute correlation coefficient in our case is actually 0.7, which is only moderate. PCA works in a way that it will capture the information encapsulated between pairs of highly correlated features. Since our dataset intrinsically does not contain any highly correlated feature, hence PCA is not expected to not working very well. So this is why PCA did not improve the performance of our classifier. On the other hand, we can see that SMOTE also did not improve the performance as well. This is most probably due to the nature of our target variable. We can see that the class imbalance problem occur for our target variable is not too extreme to an extent that might require a class imbalance treatment such as a SMOTE. Well, when we compare about different algorithms, which are the logistic regression and random forest, we see that logistic regression outperforms those models utilizing a random forest algorithm. This is most probably due to our data set having a very small size. As previously mentioned, we only have 121 instances. So when handling a small dataset, logistic regression can perform better as it requires fewer parameters to estimate compared to a random forest, which typically relies on constructing multiple decision trees. So in conclusion, our work reveals that the best performing classifier in distinguishing between loyal and non-loyal Starbucks customer is the baseline logistic regression model. This classifier is helpful for Starbucks business operators to formulate tailored business strategies. For example, loyalty rewards should be offered to loyal customers to maintain their loyalty to the brand. On the other hand, marketing campaigns should be held for non-loyal customers to boost their interest in the brand. However, domain experts should also be included in formulating more effective business strategy to optimize the outcome of this study in the future. That's all from us today. Thank you.